Okay, so today let's talk about energy balance. And here you see students studying for their exams or something, or reading. And you see that even studying, whatever we're doing, when we're doing something, we are using up energy. And you can see energy about 1 or 2 calories for just reading at that particular time. And so we talked about how we measure energy in terms of calorie. So calories is a measurement of energy, and we also know from past lectures that this energy is contained in foods, specifically those 3 energy producing nutrients. Okay, so when we're talking about calorie then, or kilocalorie, these are often used interchangeably. So here's the energy balance equation, right? What we want to do is to kind of contain or have our energy in and energy out balance. So we want our whatever energy that we're taking in to be the same as the energy that we're taking out. If we take in too much energy, more energy, or if we take in more energy than what we are giving out, energy in greater than energy out, then the scales will tip, and we will that energy, as we talked about earlier in the metabolism lecture, that energy will be stored as fat and will put on weight. If we are taking in less energy and we're using up so much more in exercise, more than what we are taking in, then again the scales will shift, and we will lose weight. Okay, one number to remember over here is that 1 pound of body fat is about 3,500 calories, and that we say it's about 3,500 calories because it's not exactly precise, it's not exactly correct, and it does differ with gender and weight. So it's a kind of estimate, a very educated estimate. So when we are thinking about energy then and calories, of course we need to think about food, because calories and nutrients are found in food, and they obviously have the potential to produce energy. So one question to ask is, how would you know how much energy is being produced? And there's a special machine called a bomb calorimeter, which burns food in order to measure how much energy is in that particular food. So when we're talking about the energy that's coming in, we know that comes from foods and beverages, and they provide energy in the form of calories. And so again, that question of how we find how many calories are in food, and here it is. It's the bomb, a simple machine called the bomb calorimeter. And essentially what happens is that it's a particular instrument, and it measures heat energy that is released when you burn the food. And so you see over here is the food that you want to know what the measurement is, and you're burning it in a special container, and which is inside the water, and it's and as you burn it, the heat is released. The heat energy is released, and as the heat energy is released, it's released into the water. And so you have this thermometer over here to measure the amount of heat that's released, and how warm the water is. And so to make sure that works as well as possible, you make sure that heat is contained, and so you have a special jacket that keeps the heat from escaping. And it also measures the change in temperature. And so this is really the instrument that's used to measure how much energy is in a particular food, or can be used for that. So the calorie then is the amount of heat energy required to raise temperature of 1 ml of water 1 degree centigrade. Okay, so that's okay, so let's have a look at how we can balance food intake. The one way in which we can balance these food intake is by recognizing the signals that our body gives us when we take in food. Okay, and so one of the ways, some definitions over here again, is things like appetite. Appetite stimulates our food intake. So when we have an appetite for something, we may not particularly be hungry, but we just may be stimulated to eat something. We may see a cake over there. We've just maybe eaten like an hour before. We're not really hungry, but we see this cake and it kind of stimulates us, right? We kind of have a feeling to have it because it looks delicious. And so that's really what appetite is. And then you have hunger. Hunger is more physiological. Our body is telling us that it needs food, right? It's a physiological response that comes from the brain, the hypothalamus in the brain, and it's really triggered by the receptors that are in our GI tract, and nerves send message to the brain, and that's the feeling, that painful sensation feeling that we have, that tells us that we're hungry, right? So having an empty stomach, causing those gastric contractions, and so on, those all will send these physiological response to the brain to tell, and the feeling is that we're hungry. Okay. So satiation is the feeling of fullness or satisfaction that occurs during a meal, and we begin to feel satiation, like I said, because we have in our stomach receptors, and they stretch and they increase certain hormones. One of them is CCK, and that sends these messages to the brain, which tells us to stop eating. And so that's a signal. Those are a signal. And then we will stop eating when we have that feeling of satisfaction called satiety after a meal. And satiety should really inhibit us from eating until the next meal. We shouldn't be having those feelings of hunger anymore, because we're satiated now, right? But it doesn't always work like that, and the feelings of satiation can be overridden. In other words, we can be eating even when we are full, and we have a way of not listening to our bodies, or just overriding those signals that the body has. So here we see how we can override hunger and satiety. And these are the situations in which it's very easy to override these responses of hunger and satiety. When we're stressed, when we're bored, when we're really anxious. Some people do that. Just before exams, you tend to eat a lot. When you're really, something's going on unusual, you may tend to eat a lot. There are also some external cues which can facilitate us overriding these hunger and satiety, like the time of the day. When we see something that's delicious, the sight and the taste of it. Some environmental influences. Not having, not being used to having food around, cognitive influences, and also some disordered eating can create these overriding of hunger and satiety. Okay, so how do we, what type of foods or nutrients help to keep us full? So protein is the most satiating of the food. So protein is the one food that makes you feel fullest for the longest, right? Also, low energy density foods, high fiber foods are also satiating. We talked a little bit about that. High fat foods may make us eat more. That's what fat tends to do. And fat also does provide some satiety signals too. Okay, so that's energy intake. Let's talk a little bit now about energy output. And when we're talking about energy, the amount, how we produce energy, some definitions here. The one is the thermogenesis, and that is essentially the generation of heat. And it's an index of how much energy the body is expending. Okay, and that's essentially what that is. When we're talking about how we spend our energy, there are different ways in which we do, and we usually think about it in terms of components of energy expenditure. And these are the ways in which we expend our energy through basal metabolism, physical activity, and also through the thermic effect of food. So let's take the first one, basal metabolism. This is about 2/3 of your total energy expenditure. Basal metabolism is also the sum total of energy that's expended on all of the involuntary activities needed to sustain life, right? Things like just breathing, just all the things that the body needs to do. This is what the basal metabolism is, and that's probably why it's 2/3 of the total energy expenditure. Okay. Things like keeping the body temperature the way, at the optimum level, things like making new proteins, breathing, just everything that we need to think about. Usually actually measured when you're sleeping. Just think about when you're sleeping, or just keeping you alive is essentially what basal metabolism is. Okay, and then the second one is energy expenditure. Is physical activity. The second one of the energy expenditures is physical activity, and that, as you can see, is the most variable one and the one that's most changeable. And I think that makes intuitive sense, right? It's variable because it depends on how much energy, how much physical activity that you do. Okay, and so the amount of the energy that we need depends on 3 factors, and that would be the muscle mass, the body weight, and the amount of activity that we have. Okay, it also depends on how much physical activity we're doing, the frequency, the duration, the frequency, and also the intensity. All of these then will influence the energy expenditure in terms of physical activity. And then the final one is the thermic effect of food, and that's really an estimate of the amount of energy that we would need to digest, absorb, and transport, metabolize, and store the nutrients. So it's about 10% of your total energy intake. Okay, so if you're taking in, your total energy intake is 2,000 calories, then the thermic effect of food would be 10% of that. Okay, your high protein foods tend to have a little bit more versus your high fat foods of that. So here's the graph over here then, which graphically just kind of shows you what we've been talking about. Here you have the basal metabolism, and it's used for breathing and and heart pumping, body temperature, and all of those fun things, and also for growth. And that's 50 to 65% of your total energy. 30 to 50% is within the physical activity, and about 10% of your energy expenditure is the thermic effect of food. This really is just showing you how much energy you expend on various activities, and so like you see, it talks about the type of activity it is, how long it is, and then the amount of calories that you expend. This file of slide over here is really just showing us that there are certain factors that affect your basal metabolism, and this is what they are. Okay, age is one of them. Growth, people who are growing more tend to have a higher basal metabolism. Men generally have a higher basal metabolism because they've got generally they are taller. Once you're taller, you have more mass over there. But then the other thing too is that they have more lean muscle mass, which tends to use up more expenditure than non-muscle mass. Age is very interesting. Your basal metabolism tends to decline as you grow older because you have less lean body mass that decreases. Physical activity is one that can be very variable, as we had talked about a little bit earlier, and so intensity would be a key over here. And then of course body composition and size. Taller people tend to have higher BMRs. The other things are environmental, like temperature, right? Things like fasting and starvation, and also just genetics. There are some people that tend to, just through genes, it may run in families, that some people just tend to have higher basal metabolic rates than other people, or other people may have slower ones than others. Okay, so yeah, that was a short one, so but that's good.